Hello, today's lesson will be on building construction for the fire service. This will be kind of a um, overview of building construction, and we'll go over how to determine what a building, what class it falls in. We'll go into some more in-depth things such as how fire will spread in that building and what kind of tactics will be needed to use to put these fires out. All right, just a little introduction. My name is Josh Wallace. I guess I'll start from the beginning. I joined the fire service when I was 15 years old. I volunteered for a Shiloh Volunteer Fire Department. I began getting my certification classes and I got a part-time job with the city of Eden. Was there for about a year and a half, and then was fortunate enough to get a full-time job with Ocean Isle Beach Fire Department down at the coast. I worked there for about another year and a half, and then was able to get a promotional position with Charlotte Fire and Rescue down at the coast as well, and became an engineer. Worked there for a couple of years, and just recently wanted to move back to my hometown. And I'm now a fireman with Durham County Fire and Rescue. We cover the eastern side of Durham County and the western side of Wake County, Raleigh. I'm also in my last semester of getting my associate's degree in fire protection technology with Central Piedmont Community College. Right, the objectives for today's class, we want to be able to identify the five main types of construction listed out by NFPA. We also want to be able to identify the components that make each building fall into that category. And we want to be able to understand the dangers of each construction type, and we want to be able to determine or understand how how fire spreads in each one of these different types of construction. And by doing so, we'll be able to understand the weaknesses of each construction type and what firefighters should be on the lookout for. There's many NFPA standards that cover building construction. There's some that go over sprinklers. There's NFPA 13, and you have NFPA 72, which goes over like different codes and how buildings should be built. And there's many different ones that pertain to some type of building construction. The main one we're going to be focusing on is NFPA 5000, and this standard addresses the construction, the protection, and occupancy features necessary to safeguard life, health, property, and public welfare to minimize injuries. The standard accomplished by it sets forth different design criteria, regulates the controls permitting design and construction practices used to build these different types of buildings. It also covers demolition and location of different buildings. You know, you can't have a industrial facility in the middle of a residential neighborhood, so that helps to protect lives as well. I'll go into the first type of construction we have is type 5, wood frame construction. This is going to be your most common type of building that firemen go into. These are going to be your residential houses, your very small offices. These are completely built with combustible materials. We'll go over a little bit of a history of wood frame construction. The United States is a fairly young country compared to other ones, so there really hasn't been a building boom since like the 1700s, is when buildings were starting to be constructed rapidly. And then in the 1900s, we experienced the Industrial Revolution, where mass amounts of people wanted to move into larger cities and build up where the jobs were, manufacturing jobs, industrial jobs. So that's where we see a big boom in these buildings, in these houses. For this purposes, I'm only going to cover two different types of wood frame construction. The most common ones we'll see, and those are going to be your balloon frame construction and your platform frame construction. Wood frame construction, those are in between the 1900s to 1950s is when that style of building construction was popular. There are some dangers with balloon frame construction. They have no inherent fire breaks built into these structures. These will have the studs that run from the basement or the foundation and will run straight up to the base or to the attic. There's no fire breaks in between. The only ones you're going to see are going to be where your windows are. But other than that, it's just a straight open void space between. each floor. This allows for easy fire spread. There's nothing there to help impede the fire from growing. And then we'll go over some identifying markers on how to determine if it is a wood frame construction or a balloon frame construction house. Here are some pictures of balloon frame construction houses. You can see here how the studs run straight up to the attic. There's no fire breaks in between. And you'll see over here in this picture as well, there's no, if you look at the studs, they just go straight up from the foundation all the way up to the attic. This allows for fire and smoke and heat and gas to just rise from a fire that's in the basement or it's on the first floor, and it'll go straight up to that attic, unimpeded. Here's some other two pictures here of just houses that are finished, and you can tell, we can assume that these are balloon frame construction. And one way, a good telltale factor is you look at the windows and the doors, they'll usually always line up together. They'll be the same size and they'll always line up in the same area. That way these studs can just go straight up to the wall or to the ceiling, and they can just stick windows in between those two studs. Those are just some telltale signs. Next, we have lightweight construction. These are built out of very, very light material, especially the newer ones today. They're made of engineered I-beams. You have gusset plates. You have fast construction, and this allows for fast construction times. An engineered I-beam, as you can see in this picture here, all it is chips of wood put together like plywood, and they're glued and pressed together. And then these are glued, the I-beams, well, that plywood is stuck in between two wood strips, and all those are just glued together. And these are what's going to be used for your floor joist and your roof trusses on some of your buildings today. You also have gusset plates, which I have a picture here, and all these are just metal fasteners that are used to connect floor joist and roof trusses together. They have these little metal spikes that stick out, and they're only like 3/8 of an inch tall, and all they do is press into the wood. And if you see them around, you'll actually see where the whole gusset plate is not even in the wood. It's just various little ones of the little spikes will be pressed in, and some of them will just be exposed. These are very light materials, and there's also a newer practice of using plastics to build houses. And we all know that plastics burn hotter, faster, and produce a darker smoke, which is not good for us firemen. And like I said, in wood frame construction, most of them are going to be made of combustible materials. All your walls are wooden, all your studs and joists are wooden, your covering such as drywall, all that's combustible. And it's going to be, interior furnishings are also going to be combustible. You also have asphalt shingles and OSB board, which are also combustible. And, all right, the next type of lightweight or wood frame construction is going to be your platform construction. These are going to be what's built from the 1950s on up to today. These types of building construction, they lay down a platform on the foundation, which is just a wood subfloor, and they'll build the joists or the trusses, or these studs up the walls, frame it out, and then on the first floor, and then as soon as they start the second floor, they will lay down another subfloor for the flooring. So there will be an inherent fire break just in between those two platforms. So it's typically just like a box stacked on top of another box. And that's how they build their floors up. These have fire breaks built in by code. They also have to be in between the studs, not only just the platform, the second floor being a fire break, but you also have to have fire breaks built in between the two studs. So that's by code. These are still constructed with combustible materials. They're made with wood. The interior furnishings are going to be wood. The asphalt shingles and your paneling and all that's still going to be combustible wood. Here's a picture of platform frame construction. You can see here you got the subfloor running along here. You can see the foundation, then the subfloor, and then you see the studs running up the walls. There's also little fire breaks in between the studs, and then the second floor you can see the next subfloor put in as your next box, and then your studs running up the walls, and then you also have your fire breaks up there. This helps to confine heat, fire, and toxic gases from spreading from one floor to the next. The types of occupancies you're going to find with wood frame construction, whether it be balloon frame or platform frame, these are going to be your single and multifamily. Your single and multifamily dwellings, they're going to be your homes, apartments, condos, and townhomes. There also you'll find these smaller offices such as doctors' offices, and some antique stores are starting to get in and renovate these older homes and move in their businesses into these homes, which is a change of occupancy from residential to a mercantile, I guess you'd say. So it's a different aspect there with those kind of homes as well. But these are going to be the majority of fires are going to happen in these types of structures. The challenges for fighting a fire in a type 5 construction or wood frame, and that's going to be, well, all the material around you is combustible. So you've got wood, you've got plastics, all that are easily ignited, and that will burn. Plastics will burn hotter and faster, as we know. You also have the traditional versus modern. If you have an older home built with thicker woods and a little more substantial connectors to the woods, we've seen the videos, and NIST done studies where it shows that traditional houses, flashover is not until 10, 12, 14 minutes. Now we get into modern day construction, and we're seeing that flashover happens at 3 to 4 minutes, or like 7 minutes at the most. And we know the firemen are arriving at 7-minute marks. So we're right there in that time frame for the flashover point. And we have the sustainability of the materials against heat and fire. Now, when these materials are engineered and designed, they're only designed to support the structure and the load that will be in it. And they work fine, they work great. But as soon as you start adding heat, fire, the glues that hold them together, the connectors that hold them together, will start to separate. And then you add the load of the water being used. Water weighs 8 pounds or so a gallon. So you start adding 1,000 gallons, it's 8,000 pounds of water inside a house that's not designed to hold that. And that's when we see floors failing, roofs failing, and walls collapsing. Just as those metal gusset plates I showed you earlier, heat expands at 1,300 degrees Fahrenheit, or metal expands at 1,300 degrees Fahrenheit. And we know that fires reach that very, very fast, especially with new plastics and stuff inside homes. So we can not guarantee, but we can expect those gusset plates to elongate and pop out of the wood joists that are holding together. And once that happens, there's nothing holding that wood together, so we can expect collapse or failure of that component. Just like in the balloon frame construction and also in platform frame construction, you're going to have concealed spaces. You're going to have spaces between the studs and the walls, in between the floors. You're going to have different concealed spaces, and heat, fire, and smoke, they're going to go wherever they, least resistance, they're going to go there. So you're going to have to, tear open walls and make sure that the fire hasn't spread to those areas. But there's a bunch of them. So. And balloon frame construction is very bad about this because, like I said, there's nothing to impede the growth of the fire. So if the fire happens on the first floor, you're going to need to go to the second or the top floor of the attic to make sure the fire hasn't spread up there. And we went over the collapse potential because these buildings, the newer ones are just failing within minutes because of the heat and the lightweight components that are being used. Next, we have type 4, which is heavy timber construction. This type of construction is still using combustible materials, but it uses large dimensional lumber to frame out the building, or these are left exposed inside. When you go inside a great hallway or an entryway or something like that, you'll see these giant beams that are exposed. These heavy frame timber allows for large open spaces. Like I said, you'll see these in churches and event venues. These allow for great expansions without having columns put in place or steel beams running across the ceiling. They use heavy timber. These will be some of your older buildings will have these as well. Pre-1960s, it was kind of a common thing to use because these larger dimensional lumber was easier to obtain and a little bit cheaper than they are today. And today's buildings, like I said, they're not as easy to come across, or they're very expensive. They'll take smaller pieces of board and laminate them together by using glue and heat and pressure and make these large beams. And here's some pictures of heavy timber. You can see this is just a great, like a large room, hallway, or an event building. You can see the large timbers that were used to use as roof joists to hold the roof up. And then here's a building here being framed out using large heavy timber. Fire behavior in type 4 construction, like I said, it has large open spans, so there's a vast amount of oxygen in the room for the fire to use and burn up. So, we all know that heat, oxygen, and, uh, and and fuel is what makes up the fire triangle and the tetrahedron and the uninhibited chemical chain reaction. So here we have a large amount of oxygen that'll feed the fire. There's also still concealed spaces in these buildings. You also have the walls that are built up on the sides. They have wood studs in them as well. You'll need to go in there and make sure fire hasn't spread into those concealed spaces and spread to other parts of the building. The types of buildings that will use type 4 construction, you'll have churches, log homes still use these types, historical buildings you may see still have them, and event venues. We know that today's designs, a lot of people like that old barn look, old log building look, so a lot of new construction is being built to mimic that style. Again, those beams are going to be laminated probably. There's going to be glued and pressed together small beams. We'll see what happens with those later. The challenges of fighting fire in type 4 buildings, like it says, large open rooms, lots of oxygen, and they have a great collapse potential because we always see when a church catches on fire, I mean, they have line of duty deaths with church fires. We see that heavy steeple up top. The beams are designed to hold that load, but as soon as they're being impinged on by fire or heat and that glue delaminates or that wood decomposes, it loses its strength, and that heavy weight on top of that building will cause that roof to collapse because there's not columns holding these things up. It's just those large open spans where those heavy timbers hold it up. Like I said, you have the newer laminated beams. Here's a couple pictures. You can kind of see where each little block stops and then how they glued and pressed together to make it one large beam. The only good thing about heavy timber is that the denser wood, it does take a lot more heat and fire to start decomposition of it. As you can see in this picture, you can see the wood is charred on the outside, but the inside is still intact. All right, the next one is type 3 construction. This is your ordinary, and this is what I like to call Main Street USA. These are going to be your buildings you see in downtown areas. The interior walls are still made of combustible materials. They still have wood studs, and the wall paneling is still made out of various combustible materials. The exterior walls, however, are made of masonry. They're either going to be your brick or your concrete type. And these are usually built in rows, and they share walls. Now, older one downtown areas may not have firewalls built in. Newer ones are probably going to have a brick wall or some kind of rated wall in between the two different stores. In case a fire happens in one store, it will not spread into the next one. And these are just some pictures of your ordinary type construction. Like I said, your Main Street USA. If you ride down any older downtown area, you'll see these buildings put up, and you'll see here they're built in rows in this one as well. You see they have a brick or masonry type outside, but the inside is still made of combustible materials. There's some challenges with these as well. Type 3 construction, these are usually older buildings. If you go like I said, these historical downtown areas, you'll see these little anchor plates on the side of the buildings. And these anchor plates actually have rods going through the building, and these are what are used to hold up the building because over time the masonry has settled and the building has started to get cracks in the walls, and they need to shore it up kind of and tighten the building up with these anchor plates and bolts to help keep it from collapsing. You'll see these on the outside of the building. And they also, type 3s are known to have their decorative cornices on the building or their dormers. You'll see them run across the top of the building. You'll see these intricate artworks on the sides and on the tops of the corners. And they also may have these large overhangs coming off of them. And these can be very dangerous. And they also can have parapet walls. There's some pictures of anchor plates. You can see them here. They come in all different shapes and sizes. They have stars, crosses, S's, and just different designs. You'll see these on the side of the buildings like you see in this picture here. And they're just painted in. They're just scattered throughout the wall. These are, like I said, they have bolts on the inside shown in this picture. And all they do is tighten up that building to keep it from falling and sagging. If you look in this picture here, you can see the different types of overhangs, the different cornices on the windows, and the dormers on top. You see the parapet wall. All this stuff is just held on through like probably metal tabs that are hooked into the rest of the wall. So if you have heat, fire, and they'll expand these metal clips, and these things can easily fall, and they can hurt firemen who are staged down here at the front of the building, and allow for no egress outside the building once this collapses. Also, the brick facade on the building is also connected to those wood frame components inside, and these can also fail and cause collapse of the outside walls. The types of buildings you're going to see built with type 3 construction are going to be your older downtown buildings, like I said, your Main Street USA. You also have merchandise stores, like smaller ones, going to this type of construction. Now, new codes, they have different standards, maybe have metal studs instead of wood studs in them. But you can see like some of your laundry mats could be made out of these, and they can, and the occupancy changes in these buildings over the years. So what could have been a general store could now be a laundromat, or it could be a storage for cardboard, and there's no fire sprinklers in these types of buildings. The fire behavior in these types of buildings is still going to be lots of concealed spaces. Again, you got your studs, you got the spaces between your walls and the floors. Like I said before, it could have changed occupancies from time to time, and the fire rating has not been changed, or no sprinklers have been updated to handle the excess fuel load that may be present in these buildings. Most of them have open stairwells that lead to the second floor. You have to worry about heat, fire, and smoke rising to that second floor and spreading fire there. They have combustible interior walls again, and the fuel load in these can change from time to time as well. They could be from metal can storage, or it could be a antique furniture store full of old combustible materials, and the fuel load could just be very high in these buildings. Like I said, they may be retrofitted with sprinklers with occupancy change, or may not. Challenges of fighting fire with these, like I said, the front masonry wall has a high potential for collapse, and all the cornices, dormers, and overhangs could collapse and fall in on the street because the materials used to connect these to the building could become heated and expand and come off the wall. And like I said, the devices used to hold those anchor plates, those threaded rods, again, heat expands those. They could come loose and pop out and allow the whole building to collapse, because what was holding it up has now lost tension and could have caused the building to collapse. Fire spreads through concealed spaces, and you have combustible fuel loads in these buildings. Next is type 2, which is non-combustible. The building materials of these types of buildings are non-combustible. These are going to be your concrete floors, your steel studs, metal roof joists, and you're going to have masonry, or you're going to have metal siding on these buildings. These are going to be your newer buildings that are being put up for merchandise such as auto stores, your Walmarts, and things like that. These are going to be your large box stores, and they're going to be your kind of smaller buildings such as that. They can also have masonry wall or tilt slab concrete wall. The roof system, again, like I said, they're going to be made of metal roof joists, probably open. You can be able to see them. They'll have a membrane over top of that for the roof, or it could have a concrete roof or insulated foam. Here's some pictures of a type 2 buildings being constructed. This one you can see the metal roof trusses here on this one, and you can see how the concrete wall is being built up around it. Here again is another, it's like an apartment building or some condos or a hotel. Again, you can see the metal studs that are running or built up the walls, and you have these concrete tilt slabs being put up in place as the wall for the exterior. And then here's a finished one. These are going to be your new stores, such as your phone stores. These are going to be all the ones you're seeing in your new strip malls and new buildings constructed like that. And these are going to be your type 2 non-combustible. Various types of buildings, like I said, newer commercial properties. If they come in and remodel an older commercial property, they'll probably update it to a non-combustible. And they can be varying in size. They can be your large Walmarts, your Costco's, large box stores, or they can be your smaller stores such as your O'Reilly's, your AutoZones, eyeglass stores, stuff like that. Fire behavior, again, there's going to be large open spaces in these. Like, you've walked into a Walmart or Costco, you see these just vast open areas. So you have to be careful of the oxygen supply that's into these buildings. It's going to be unlimited. You're not going to take that part away. Quick fire growth as well, especially depending on the fuel load inside the building. If you have a tire storage place or a cardboard storage, you can expect that to be a great fuel load and a great fire to spread very quickly compared to a metal building that houses like metal cans. Challenges for fighting fire in these types of type 2 construction, again, it's going to be your large open areas with limited amount of fuel supply. Also, these large buildings, it's going to be hard to maybe find to see the fire or to evacuate these buildings. So there's going to be large open areas for these firemen to search and try to find and see the fire in this hot, dark environment. And they can become lost very easily. And we don't fight, but firemen in general do not fight lots of commercial style fires. So they're they're one of those high or low frequency, but it's just something we don't go to very often, and they're very dangerous for firemen. Again, the metal roof systems that are put in, the metal roof joists, the heat will cause those roof joists to expand. They push out on the outer walls and can cause collapse. Also, if you notice on these larger box stores and other stores in general, the AC units are placed on top of the building. They're put on top of the roof, not on the floor or ground level. So as long as there's nothing, the building is engineered to hold that kind of load. But when you start throwing heat and water and extra loads of water up there on top of that roof, where you have heat impinging on those metal roof joists, making them weak, those heavy weighted AC units can easily make the wall collapse or the ceiling collapse and push the walls out, making them collapse as well. Also, you have a high occupancy hazard in these types of buildings. Again, if you look at a Walmart or Costco and you see how many people are there at one time, if fire breaks out, people can be able to evacuate. The large fuel loads. Fortunately for these types of construction, they are sprinklered. They do have sprinkler systems in them. Again, there has been reports, of failed sprinkler systems not working correctly or they weren't properly fitted in the area. I know you see like these in-rack sprinklers at Lowe's that are supposed to, if a fire happens in a rack, the sprinkler inside the rack is supposed to put the fire out, but sometimes something's blocking that sprinkler or the sprinkler's been damaged and it doesn't work effectively. There's also standpipes for these, so you don't have to carry your hose throughout the whole building. You can go to a standpipe inside the building, hook onto it, and then go fight fire. And they have FDCs, which is used for the fire department to hook up to supply the sprinkler system. And the last type is fire-resistive construction. These are going to be your most protected buildings against fire. They are built with fire-resistant materials. So all the walls, the floors, the roof, everything's going to be made of concrete, or it's going to be steel with a protective coating sprayed onto it. Probably it's concrete as well, sprayed onto those steel beams. Like I said, the outside walls are made of concrete. The support systems are constructed with steel or concrete and have a protective coating on them. The roof system is also made of concrete, but the interior finishings will probably still have some kind of combustible materials. You have like an office building or hotel, that like the outside and the inside walls are made of concrete, but then they put drywall, they put combustible furnishings inside the room, and those can still ignite and cause a fire. Here's some pictures of some fire-resistant construction. You have a parking deck here. Also, most of your major high-rises or all of your high-rises are going to be fire-resistant construction, and you can see here a picture of some kind of concrete or fire-resistant coating has been painted on, or sprayed onto the column and the roof joists of this building. The types of buildings are going to be your high rises, and a high rise is defined as anything over 75 feet tall and or out of reach of the fire department's aerial devices. So if you have a 75-foot ladder truck, then 75 foot or higher is going to be a high rise. If you have a 100-foot, 75 is probably still going to be considered a high rise, but you can reach the top of that with your 100-foot. Also, your park garages and industrial facilities are going to be made out of fire resistant or type 1. Fires can still occur in these types of buildings. There have been cases of hotel fires, casino fires, and unfortunately, has come on the anniversary. We had the major attack on the Twin Towers. That was a fire resistant building that ultimately collapsed. But typically on a normal fire, it's going to be held to that room of origin because there's going to be sprinklers in there probably, and also due to the fire resistant construction around the building or around that room, it's not going to allow it to spread. And fire protection are added. The fire resistant material though can become compromised. The coating can be chipped off by maintenance or just through everyday working environment, or when the building has to be retrofitted with fiber optic cable or telephone lines or cable lines or anything like that, they may have to be drilled into, and the fire resistant material may come off of it. And now you have a hole through the concrete or the column or the steel member that's supposed to be supporting the roof, so the fire can spread through that hole and go into another room where the smoke can too as well. And ventilation can be very challenging in these types of buildings. You have a large high rise, you're trying to vent out the room. It could be well above, the reach of aerial devices, and so you cannot bust the window out, do horizontal ventilation, and also those windows may be made of very hard material. And it could be on like the 14th floor, so it's very hard to access, and it may not have may not be directly above the actual top of the roof. So vertical ventilation is very challenging due to the material and just from the location to the top of the roof of the building. To ventilate, you may have to shut down the HVAC systems, which is the heating and cooling of the building. These systems can pull in the smoke and heat from one room and push it into the other various parts of the building. And also, if you do want to ventilate, you can open the door of the building and evacuate the stairwell next to it and pressurize the stairwell to push it up and out of the building. Challenges to fighting fires in Type 1 construction. Access to the fire floor is going to be your main challenge. Like I said, it could be on like the 28th or 70th floor of the building, and that could be very taxing on getting equipment, hose, full turnout gear, everything you need to fight the fire. Very taxing on firemen to get it up there. Ventilation challenges as well. You got your thick windows, your accessibility to reach the building, and no roof to cut the hole or cut a ventilation hole for. And also, you have the potential for high occupancy in these buildings. These are going to be your high-rise buildings. There's going to be thousands and thousands of people in these buildings. Fortunately, for fire-resistant construction buildings or Type 1, the tactics normally used if there's a fire on, say, the 14th floor, the only ones that really need to be evacuated are going to be the fire floor, the floor directly below the fire, the floor directly above the fire, and then the top floor. So this will eliminate you having to evacuate all 100 floors of this building and only have to do 4 of them, which is more doable. In summary, all right, fires occur in various types of buildings. We've all seen on the news, or we've experienced them firsthand, fires in all types of or every type of construction in this presentation. So none of them are immune to fire. Firefighters should be conscious of the dangers that are in each type of construction when on fire, such as your Type 1s, your fire resistant. That's going to be just challenging getting accessible to them. Your Type 2s are going to be the large open oxygen spaces and trying to see the fire in a large building. Your Type 3s are going to be the dangers of collapse of those masonry walls and cornices and stuff like that, and the concealed spaces. Your heavy timbers, again, are going to be collapsed due to the large open areas and heavy loads on top of the roofs. And then Type 1s, of course, are going to be just the lightweight material. By understanding building construction, a firefighter can become or have an idea of how fire will behave. You know how some of the fire will spread in a Type 2 building or a Type 4, Type 5. They can expect, where to check for fire spread or know that the fire may go this way or that way, and they can kind of get ahead of it to stop it. And they can do this by knowing the types of different buildings. So knowing what type of building you're going into will give you advantage. Knowing the components that make up the building. So is it going to be safe to enter if we do this kind of tactic, or is it not going to be safe? And knowing how the fire will spread throughout the building will help you to help extinguish the fire quicker and safer, to help keep firemen safe and the individuals we protect in our community. And that's all that I have. Thank you.